right, we are on page 41 in your books. We're going to do Unit 1, Lesson 11, What is the Same? So for this one, the starter activity here on page 41, it says, let's decide whether these shapes are the same. And it says, find the right hand. So it says a person's hands, palms down. So that's important. Their palms are down. Are mirror images of each other, which, yeah, you hold out your hands, palm down, they do look like mirror images of each other. In the diagram, a left hand is labeled. They're asking us to shade all of the right hands. So take a second, maybe pause the video, see if you can shade in all of those right hands. All right, let's see how we did. So if I'm looking for a mirror image, essentially, and I'm looking for these right hands, I notice, and I'll use my highlighter here, first off, the one right beside the left hand mitten looks like a right hand. Again, we're saying palms are down, right? This one, it is just like that one. It looks like a left hand, so I don't think that one is it. The one below it, I don't think that one is it either. Palm down, that looks just like the left hand. However, I see another right hand right here. Right, if I turn my head, I can see how, yeah, that does look like a right hand palm down. And here is another one right there. And then finally, this last one, I've got to really turn my head to see if that's a right hand or a left hand. And you know what? It looks like a left hand if it's palm down. So there we go. I've shaded in all of the right hands. And again, that's just getting you guys to realize, and you already knew this, but that the hands can look like a mirror image of each other, right, when I'm holding those out in front of me, both palm down. All right, so go ahead and turn to the next page. We're on to the meat and potatoes of the lesson. I've got 11.2 on page 42, and it says here, for each pair of shapes, decide whether or not they are the same. So again, same thing here. Take just pause the video, and then you can play it when you're done to see if you were correct or not. Pause the video and just see if you can identify if they're the same or not. My hint to you would be use patty paper. All right, let's see how we did here. So it says, just say if they are the same or are not the same. Well, I noticed when I did this activity and I used patty paper that that was a yes. These two shapes here, those are the same. I traced one out on my patty paper, and all I had to do was turn it, and it got me the other shape. So I'm saying yes. Why? Traced out on patty paper, traced out on patty paper. Struggling with this pen right now. Trace out on patty paper. They are the same. Now for B, I didn't have to trace that out on patty paper, and hopefully you didn't either. I can tell just by looking at these two parallelograms that is a no, because they don't have the same angles, right? They're not the same angles, so not the same angles. I didn't have to use my patty paper for that one. For C, I did the same thing. I used my patty paper, and this time instead of doing a rotation to get it to fit like I did for A, I noticed that all I had to do is flip over my patty paper. In other words, just do a reflection, and the answer was yes. So those are the same shape. It's just one is a reflection of the other. It's kind of like the hands that we just did on that last activity. So yes, for C, and it's because they are a reflection of each other. All right, circle C. For D, it looks like they're trying to do a reflection here, but the shape on the left is much bigger than the shape on the right. So I'm going to say no for D, and my reason is the side lengths are different. You can tell that. It doesn't even pass the eye test, right? So no, sides are different. Side lengths are different. And then I'll scroll on down so we can see E a little bit better. When I look at E, it does look like it passes the eye test. So I traced this out on my patty paper, and when I went ahead and moved it from the one on the left, I traced this one out first, and when I put it over here to the one on the right, these little, I'll highlight them, these little outward pieces did not line up. So on the puzzle, those little outward pieces did not line up. So I'm going to say no. What should I call that? The puzzle pieces aren't the same. That's what I'll call it. The puzzle pieces aren't the same. Or I guess I could say they are different. All right. So you guys could probably get that correct pretty easily. Maybe E was a little tricky because it does look like it's the same puzzle piece, but when you actually trace it out and then move it over, you realize that they're not. So what does it mean to be the same, right? I think the first thing that we all do is just see if they even look like the same shape, right? What does it mean to be the same? Well, do they have, I mean, they got to look the same first. Look the same. Like we could tell right away, D, those are not the same shape. They don't match up. But E, even sometimes if they look the same, that's not enough, right? We have a bunch of bullet points we're going to try to fill in here. Because if they look the same, that doesn't necessarily mean that they are the same. And we found that out with E. I think using those words that we've talked about before, congruent, right, is the same. So, are the sides the same? Side lengths, I should say. Have to be congruent or all, have to be the same. And that gets me thinking to, rigid transformations. We talked about how not only are the side lengths the same, but the angles are the same also, right? So I'm going to put that angles have to be the same. Angles have to be the same. And that's actually, what we just described, side lengths are the same, it has to look the same, angles have to be the same. So to be the same, basically it just means that you're able to do a rigid transformation to get from one shape to the other, right? If you can't do a rigid transformation like in D, there is no rigid transfer, there's no reflection, translation, or rotation that takes this shape from D to this shape. Because they're not the same, right? And that gets proven because there is no rigid transformation that takes one to the other. So what does it mean to be the same? I'm going to put able to get the image through rigid transformations. Woo! That's a long word. Okay. So, We know what it means to look the same, to be the same. What we're going to look at next is just these different rectangles. So I'm on to page 43 now. We have all of these rectangles. Luckily for us, they're labeled A, B, C, D, E, F, and then R is our one at the top there. It says here, which of these rectangles have the same area as rectangle R but different perimeters? Okay, so we actually had area and perimeter questions on our last assignment. If you guys remember, we had all different kinds of shapes you had to find the area and perimeter of. So we already know area is found from rectangles by doing length times width, right? So I'm going to write the area on the inside of each of these rectangles, and then I'm going to write the perimeter, which is the distance all the way around the shape, on the outside, but right beside each one, okay? So for R, 2 times 3, I'm going to put a 6 on the inside, but then on the outside, 3 plus 3 plus 2 plus 2, right? If I added up all the sides of that rectangle, 2 plus 3 is 5, 2 plus 3 is 5, and 5 plus 5 is 10. So that one has an area of 6, but a perimeter of 10. And then I'll just do that for A, B, C, D, E, and F as well. That way I can answer these questions. So for A, I've got 3 times 2, which is 6, and then 3 plus 2 plus 3 plus 2 is 10. For B, I have 6 times 1, which is 6. It gives me an area of 6. 6 plus 1 is 7, plus 6 plus 1, which is 7 more, 7 plus 7, that gives me a perimeter of 14. For C, I have 1 times 6, so my area is 6. And then add up all the sides to get the perimeter. 1 plus 6 is 7, 1 plus 6 is 7, and that gets me 14. For letter D, 4 times 1 is 4, so my area is 4, and then add up all the sides. 1 plus 4 is 5, 1 plus 4 is 5, so that gives me a perimeter of 10. E is 3 times 2, which gives me an area of 6, and then 2 plus 3 is 5, plus 2 plus 3 is 5 more, 5 plus 5 is 10, it gives me a perimeter of 10. And then last but not least, letter F, 4 times 1 is 4, and then add up all those sides. 4 plus 1 plus 4 plus 1 is 10. All right, now, let's answer number 1. Which of these rectangles have the same area as rectangle R? Well, rectangle R, we found out, has an area of 6, right? So I want to highlight these ones that have the same area. So I have an area of 6, but different perimeters. So the perimeter of rectangle R was 10. So I want to see which ones have an area of 6, but a perimeter that's not equal to 10. And when I look down through here, I can see that that is rectangles B and C, right? Because B has that area of 6, C has that area of 6, but they both have perimeters of 14, not 10. That's fitting that criteria. For number 2, which rectangles have the same perimeter but different area? So they're referring back to rectangle R. So again, rectangle R has that, just highlighted it for you, perimeter of 10. So same perimeter. Which other ones have a perimeter of 10 but a different area? So an area that's not 6. And I can see that that is D and F. D and F, because they both have a perimeter of 10, but their area is only 4. And then, hey, there's the bell. That doesn't mean it's time to go yet. For number 3, it says which have the same area and the same perimeter, and that is the very first one we did, rectangle A and rectangle E. They both have an area of 6 and a perimeter of 10, right? So it says use materials from the geometry toolkit to decide which rectangles are congruent. So remember, congruent means the same as or equal to. So which which of these are congruent, meaning that they are the same shape. Well, when I look at that, it says to just shade it. You guys can just use your pencils, just shade them in, right? I'm going to use the highlighter because I can, because I'm on the iPad. But we're talking about, rectangle R. Which of the other rectangles are congruent to that? Well, it's the ones we just ended with, the ones that had the same perimeter and area. They couldn't have just one, right? They couldn't be just the same perimeter or just the same area. They have to have both things to be congruent, the perimeter and the area. You could say, if you were confused about what exactly it was that you're doing here, you could say with different colors the other rectangles that are congruent. For instance, we know that rectangles D and F are congruent, right? It's hard to do with different colors, but what you can do is, instead of shading the entire thing, put stripes in it. Just put stripes in these other two that are congruent, D and F. And then, while we're at it, look, B and C are congruent also. They have the same perimeter and area. They have the same side lengths. So you can do something a little different with those. Maybe do the squiggly lines instead of shading the whole thing to show that they belong together as well. They're congruent. All right. That's how we can get around that whole using the same color without using the same color for each and every one of them. Because if you just shaded them all in with your pencil, it would not look any different at all. All right, so we have some questions that you guys should already know the answers to based off of these activities that we just did. First one, how can you check if two shapes are congruent? Well, that means the same, right? And we already answered that question. How do we tell if stuff is the same on page 42 on the previous page? What did we put there? We put that they needed to look the same first off, right? How can you check if they're congruent? First off, just make sure that they look the same, right? But then you need to see if the angles are the same, the side lengths are the same, and it is rigid transformations that can take you from one to the other, right? So what I'm going to put here is, side lengths and angles have to be the same. Side lengths and angles have to be the same. And you want to make sure that, once you've checked that the side lengths and the angles are the same, that they even look the same, right? We need to make sure that they just even look the same. Are a shape and its mirror image congruent? Well, yeah, right? Because a reflection is how you get a mirror image, and a reflection is a rigid transformation. So my answer is yes, because a reflection is how you get, is how you get a mirror image. And a reflection is how you get a mirror image, and that is a rigid transformation, which, as we've stated many, many times, a rigid transformation keeps side lengths and angles the same. So yeah, they are congruent. What are some ways to know that two shapes are not congruent? Well, if they have different side lengths or different angles, right? Or if they just look different. If they don't look like the same shape. So if they have If they are different shapes, let's put that down first. If they don't even look like the same shape, obviously they're not congruent. If they are different shapes. Or they can look the same, but if they have different side lengths and angles, then they are not congruent. If they have different side lengths or angles. All right, and then the last question, what are some properties that are shared by congruent shapes? And that's just what we've been saying over and over and over again. They have to look the same. So in other words, they have to have the same number of sides and the same type of sides, right? The side lengths have to be the same, and the angles have to be the same. But then going further, you guys found out from this activity, another way of saying that is to say that the area and perimeter are the same also. It's not enough to have just the same area or just the same perimeter. If it's both of those things, if they have the same number of sides, the angle measurements are the same, and their area and perimeter are the same, then you know it's congruent. Or yeah, that's shared by congruent shapes. So that's what I'm going to put here. They have the same number of sides, same number of sides, same side lengths, same side lengths, same angles, and same area. I think same side lengths is you're saying it's the same perimeter, so that's why I didn't say perimeter. But yeah, having the same area. All right, so you are ready for your assignment on the next page. That's on page 44. Complete that, and make sure you ask your teacher if you have any questions.